So what we're going to cover today is chapter 13, which is the expert system. I know we talked about it a little bit last week, but we're going to do more detail, definitely more detail this week. We're going to go over a lot of the filtering. So if you don't want to go to the expert system, you just want to filter it by the severity, we can do that, not a problem. And we'll talk about a lot of the caveats about the expert system, why some of it will be false positives. Actually, a lot of it will be false positives. And then we're going to spend the majority of the time on chapter 14, which is TCP/IP analysis. And the reason we're going to spend a lot of time here is that some of you guys asked for real-world examples, so this is where we're going to get real-world examples, and it's probably going to help you the most out of a lot of the chapters that you've done so far. So everything before was a lot of definitions, click this button, click that button, stuff like that. This one's actually going to be, okay, if you run into this at work, try this. And it's going to be 2 chapters today. Usually we cover 3, but we're going to spend the majority of the time on chapter 14. You can see it's kind of long here. So once again, 70 minutes. If I start getting close to 70 minutes, just remind me in the chat window. And let's see, any test passers, test takers in the past week? Kind of our regular feature here. So anyone going for anyone got their CCENT, CCNP, CCNA regular? All right. And if you're looking at the webcam, you're seeing me turn my head a whole bunch, and that's because primary screen's in the center. This is the primary screen. When I look this way, that's the chat window. And then when I look that way, it's my secondary monitor. I'm monitoring stuff, mainly BitTorrent, but I'm monitoring stuff. Okay, fire up your Wireshark. We're going to talk about, we don't need to capture anything yet, but just have that opened up. Then we're going to talk a little bit about the expert system. And then we're going to do a lot of hands-on. So expert system, you find it in the bottom left-hand corner. It's that small red button that we're going to click on. Very similar to the event viewer inside of Windows. You've got the event viewer. And actually in the chat window, who does not know how to get to event viewer inside of Windows? Anyone not know? Because when you talk about something, hopefully everyone in the room knows. But if you don't know how to get to event viewer in Microsoft, just say in the chat window. Alright, okay, so all of you hopefully should know. So you've got errors, which are the highest in severity. You've got warnings, one step below. Warnings are good for seeing a lot of things, TCP warnings. Errors, a lot of times, not that useful. I find warnings to be a little bit more useful. Things like congestion, that's where you see TCP window full, just things are transferring a bit too fast. TCP 0 window, which is basically saying, I don't want any more. We've got some notes, chats, details, and packet comments. So packet comments, you can see all the packets that you right-clicked and you added a comment to. So pretty useful information. Sometimes you want to go here first just to see kind of what's going on. I tend to go to analysis first. And I personally don't like going to expert system because I find it's cheating. I do everything by the filter box. But some of you guys may like the expert system as like your go-to thing to look at. So let's take a little tour. Let's go into Wireshark. We're going to go to our capture options here. So capture options. And then go into pick whatever interface. So mine's going to be wireless network connector. Uncheck all the crap in the bottom right hand corner. This should be automatic by now. So uncheck all that automatic stuff. And then click start. And it's going to start firing up. Okay. So we're going to wait a little bit. You'll see the number of packets in the bottom left-hand screen, or bottom left-hand corner. And then after you get a couple thousand, just click stop. It'll come up really quick because you're on a video session. Right. So what the expert tips is for is you got thousands of packets here, and yes, after you play with Wireshark a lot, you'll be able to see just kind of by eyeballing everything the problems, but probably much easier for a lot of you, especially if you're beginning, to go in the bottom left-hand corner, see this red circle, very mysterious red circle there. If you click on that guy, you're going to get a window with a bunch of tabs. So errors, warnings, notes, chats, and so on. And so it's going in severity from left to right, most severe on the left, and then it goes downwards as you go to the right. So we've got some malformed TCP, and as you click on the particular packet, it may help you if you move this window down to somewhere like this. Also, what you can do is you can resize your window. Let's see here if I could do this. There we go. You could do something like this where you shrink down your main Wireshark window and then keep this kind of off the side. If you've got a secondary monitor, I think you should be able to put this over on a secondary monitor. Yep, works just fine on a secondary monitor. So, if you can help it, always get a secondary monitor. It just makes your life a lot easier. As you click on the packets, you'll see the appropriate packet highlighted in the main window. It jumps to that particular packet. If we click on warnings, your screen will be different than mine, but I've got like connection reset. Ooh, RST. We'll talk about that later. Previous segment not captured. This is very, very common when you first start off. And that's because you started capturing when a conversation was already going. So conversation was already going. Alright, we've got some notes here. Notes are not that big of a deal. Some duplicates and stuff like that. Retransmissions. Time to live greater than 255. Ooh, that's pretty cool. Some chats, more information stuff. Oh, this is interesting. Connection establish request 443. So I opened up a SSL conversation. So that's pretty cool. Connection finish, FIN. This is where we basically say, okay, we're done talking. Let's cut the connection and give back our ports. And then details, you're just going to get bombarded with a whole bunch of details here. And then packet comments, if you had any comments. Now you don't have any because you probably didn't put any packet comments, but we can quickly solve that if we close this out. Go back into any packet, right click, and click on packet comment. So click on that guy. Oops. Blah, blah, blah. Click OK. Then as you click down here in the bottom left corner, you've got one packet comment there, and it'll tell you what packet it's on. Okay, now if you don't want to use the kind of the cheat method by going down here in the bottom left hand corner and clicking on that red button, you can filter in by the expert info by putting in filter dot expert dot severity equals, and then you could do like error and stuff like that. So let's see what we can do here. Expert. Click on filter here. There we go. See if we can search for it. Should come up. No, maybe not. Expression. expand out the expression. Let's see if we can find it in here. Probably have the syntax wrong. Expert info. Expert info group, expert info message, expert info severity. So filter expression, scroll down to expert info, find the severity, click OK. So we have expert severity, and we should be able to double click error. Okay. Now if you're on, the reason why we've got underscore WS, there's going to be some differences whether you're on LAN or whether you're on wireless. So usually you should be able to type in WS, or you should be able to type in expert.severity and double equals. Okay. But if you ever have any problems where you're typing in something and it's just not coming up, like, oh, for sure this should be coming up when I type in filter, it's not turning green, you can always get the listing by going to expression, this is everything that you could do, and clicking in here. Because sometimes the syntax may be just a little bit off. Okay. So underscore WS on mine. Got expert group, expert message, and expert severity. So with expert severity, expert.severity equals, you could do the same thing. You could look for error, you could see it turns green, you could look for a warning, you could look for a note, you could look for chat, right? Same deal. With group, it's pretty cool. Expert.group. Here you can look for checksum, I think. Yeah, checksum, sequence, malformed, all that good stuff. Okay. Doesn't look like I have any checksum errors. Any sequence errors? Yeah, we got some sequence errors there. So I'll paste in the chat window the filter that I used. Actually, I can't paste in the chat window because it's on another computer, but I'll zoom in. So if expert.group double equals sequence doesn't work for you, then try underscore ws.expert.group. Now don't be alarmed, you're going to see a lot of red on black, a lot of sequence errors, and a lot of this is going to be false positives because you started the capture in the middle of this video stream, and Wireshark freaks out because it goes, whoa, I'm seeing this sequence number but I didn't see the one before. Alright. And for the checksum errors, you're going to get those just because your NIC card is trying to offload everything and it messes up with Wireshark. If you want to cancel that, if you want to stop the checksum from happening, the checksum validation from happening, you can fix that by going into your preferences. You can go to Edit, Preferences, Protocols, and for IP you're going to go to IP. For TCP you're going to go to TCP. That's probably the better bet here. So TCP, and let's see what we have here. We're going to come back to this as well, but what we've got is timestamps, track in flight, analyze sequence numbers, and we've got validate, there we go, validate the TCP checksum if possible. So if that's checked, you're going to get a lot more errors. We'll stay here since we're on this screen anyways. The cool one is I like track number of bytes in flight. That's the middle check mark there, the middle selection. It's the one right under the drop-down box. What that does is it will show you that, okay, well, this particular conversation has 50,000 bytes to go. You know, there's still data waiting to be sent. So that's probably one of the most important ones. Relative sequence numbers here. So when the conversation sets up, you're going to use a sequence number that's probably a big, massive number. And what this means is when you talk, let's see, client and server, when you first start the conversation and you send your SYN, you're going to have a sequence number. And you know, let's think about this. If you always used a sequence number of 1, then an attacker knows this and can spoof a lot of stuff, right? So what the client does is it picks kind of a random number. It's like 2 to 1, God knows how many. I think it's 2 to the 32nd power. So any number within there. So let's just pretend it's like 400,000. That's just horrible. Let's say 400,111, right? And then what the server has to do, the server has to respond to that and say, okay, I see that you want to use 4,011. Let's start with that. And then the next one will be 400,112, 400,113, and so on. So it is a security mechanism, but it's also just kind of like an extra gut check. Right? So Wireshark, it would be really silly to always display these big numbers because it would fill up a lot of screen, and really what does it give you? So relative sequence numbers means it's always going to start at 0 when you look at the Wireshark side, but just remember in your head that it's always these big large numbers. And so what we could do is we should be able to see this. Let's take a look at this. Clear out all your filters, and let's filter by TCP. Get rid of all that ugly video all that ugly video UDP out there. Just scroll to any TCP packet. We'll just click here. So right here, if you expand this out, so expand out transmission control protocol, the TCP portion, you'll see down here that there is the sequence number. I have it highlighted. So sequence number 562,661. And of course it's telling you it's a relative sequence number. Right? Relative sequence number. So let's see what happens if we go back up here to preferences, edit preferences, protocol, TCP, all the way down here. And then uncheck relative sequence numbers. Let's see what happens here. And click OK. Alright, so looking at that same packet, let's go down here to sequence number. You can see it's this big, ugly, monstrous looking thing. And what's that? 2,675,000,000, whatever. So, definitely a little better when you have relative sequence numbers in there. Right? Was everyone able to uncheck that relative sequence number box and see the true sequence number? Everyone able to do that? Alright, cool. And let's go back to edit preferences and turn that crap back on. So user interface statistics, they're not statistics. Protocols, expanded out, TCP. And then relative sequence numbers, click OK. And it's a much more manageable number right now. So that's the expert system. That's taking a look at the different severity, and pretty easy. Might be one of the first places you go just to kind of get a sense of what's happening on that particular capture. I just noticed on the video stream that my cursor has a black box around it for some reason. That could be because of Camtasia recording at the same time. Yeah, I guess it could be Halloween. Actually, I know what it is. Let's see. Probably not a good idea to be changing mouse settings. There's a hardware and software mouse setting, and the reason is I use a program called Lux, and I don't know how many of you know about Lux, but it's to help you sleep. Turns your screen more red, kind of a reddish tint, orange tint as the night goes on. F Lux. It's a great program. There we go. So f.lux turns your screen a little bit reddish, and that helps you sleep because the blue in the LED just jacks up your sleeping patterns. Now the problem is normally your cursor will be freaking bright blue when you use Lux, and there's a setting to turn it to make it, I think it's a software cursor and trails and all that stuff, and it will make it the same color as the screen. So that's maybe why you see the black box. That's your trivia Jeopardy for today. Okay, that was chapter 13. Chapter 14 is the fun one, TCP IP analysis. We're going to try to spend the majority of our time, we will spend the majority of our time on this because it's fun. It's why you use Wireshark is to find this crap, right? To find problems in your network. So the main problems in TCP IP communications: delays, duplicates, name resolution, meaning DNS foobar, you look for the wrong name, DNS doesn't respond, you have the wrong IP for the DNS server, stuff like that. And security like firewall lets everyone in type thing, or firewall is just blocking all the ports. So when you're information gathering, you always want to know the name of the service, or the name of the computer, the name of the server. You want to find the IP address, and you want to see what ports we're talking about. Very, very, very important. So let's take a look at something. Let's go, and we're going to clear out, we're going to start a new capture. Let's do that. Let's go to capture, options, and before you do that, let's do this. Open up a command line prompt. Okay, so turn off all your captures. We're just going to try something here. I'm going to find a server that should not ping. Okay, so if you ping CNN.com, you'll get a request timed out. If you ping eBay.com, okay, request timed out. Okay, if you ping all 8s, okay, there we go. We got a good one. Okay, so we know now that eBay and CNN don't reply, and if you ping all 8s, that's definitely going to reply. Okay, so keep your command line window up or available. go back to Wireshark capture options, capture on the appropriate interface, in my case is wireless network, uncheck all the crap, and click start, and you can continue without saving. So here we're capturing, we're having fun. Go to your command line window. Let's ping all 8s. So you always want to know how things respond normally. Let's ping CNN.com. Right, everything's dying. And now let's go into one of your browser windows. So you just open up another tab in Chrome or whatever, it doesn't really matter. And now we're going to actually go to CNN.com. Enter. Right? Okay, CNN.com comes up. And then you could close that particular window, and you can minimize the command prompt and stop your capture. Alright. So you may have thousands and thousands of packets. No worries on that one. It's sometimes that just happens. If you want to save the capture, just go ahead and save as if you want, just in case your computer crashes or whatever. Alright, so let's take a look at a very useful statistic that helps us visualize the TCP conversation. So the SYN, ACK, and the ACK. Right? A lot of books talk about it, and I have the handshake process right here. We have step 1, the client sends a SYN to the server sends the SYN ACK, all that good stuff. Yeah, it's nice to talk about it, but it's even better to actually see it in action inside of Wireshark. Easier to remember, easier to visualize. So what we can do is we can go up here to statistics, right here. Statistics. And we have conversations. We have HTTP. We have lots of things we can look at. So if we go to conversation list, kind of almost in the middle there, and then TCP IP, and click on that, you can see these are all of our ports and stuff, right? Our addresses. This address, talk to that. This address, talk to that. Now, your IP address should be on the first column there under address A. So address A should have all your ports and stuff like that. And the target is going to be in address B, where you're going to. Right, lots of stuff there. So if we click on, let's see, the one for CNN. CNN was 157.166. 157.156. Now it depends. If you hit a different load balancer, then you're going to get a different IP address. Right? So in my case, it was 157.166.226.26. I'm going to click this top button here under address B. That's going to organize the IP addresses so I can find things. So I'm going to scroll down to 157. So I've got 157.25.32.207. So what's happening in the background is I'm hitting kind of the main CNN, probably a load balancer, a front device there, and then it fished me off to another web server. And finally I get to the actual web server. If they're smart, it's probably maybe all VMware, all virtualized, and they can spin up servers as as things get busy. But what we'll do is click on any of those CNN looking IPs, and then what you can do is you can click on the graph button in the bottom right hand corner here, the graph button, graph A to B, and this gives you a trace should give you a trace. I don't have any info there. Let's see what we got here. Oh, nothing there. It looks like that wasn't too exciting. Let's clear that out. Go back to statistics, conversation list, TCP IP. There we go. All right. Reorganize my addresses, find my CNN IP address, 156 something. Let's pick one with some data in it. There we go. Okay, 14 packets. Let's see if graph A to B looks interesting. Okay, so it's very faint. You'll have to see it here. We have our sequence numbers. I've got a sequence, you can barely see it. So sequence numbers and the times down here. That's over the number of seconds. So when it starts, how long it goes, and when it ends. There's another graph that you can look at if we go back to statistics and conversations. Statistics and conversations. Let's see what we can do here. TCP address B 157.226.32. You can pick any of these guys. Let's see if we can find something different with follow stream. I want to see it get an interesting one. Okay. Follow stream gives us the data. You saw this last week. See IO graph. I think I talked about that. The IO graph was number of seconds, not too big of a deal. TCP stream graph. Yeah, this is a good one. Statistics, TCP stream graph, and time sequence graph. TCP trace is that second one there. Click on that guy. No, two ways of getting to the same place. So usually in Wireshark there's like 3 different ways of getting to the same deal. Okay. Now, if you type in tcp.stream, and you say EQ, you'll get the particular stream. So TCP stream, let's do equals 1. That's going to be the first one. If you scroll to the right a little bit, under info, you'll see all the sequence numbers and the ACKs. So what you're seeing here is when you see sequence number 1 and then these ACK, ACK equals this or that. What that means is your computer has sent out a bunch of data, a bunch of packets. And the other side has said that it has seen up to 278. You're basically saying I've seen 278 and here's a whole bunch more. As the other side gets the data, it's going to acknowledge and say, okay, well, I got up to number 10, or I got up to number 30, or 40 or 50 or 10,000 or whatever. Right? So eventually these numbers on both sides should go up as information is being sent and also received. And it's normal for things to kind of jump up in big numbers, especially when you're doing video file transfer and stuff like that. Okay. So if we click on one of these, any one of these, you'll see down here under Transmission Control Protocol, sequence number 1, acknowledgement 278 on my particular one. And you see a window size. In my particular case, 17,640. Now for this particular one, what the window size is how much data can I send before the other side sends an acknowledgement. Okay, so I can send a whole bunch of data, 17K if I want, and then I'm going to stop and wait for the other side to acknowledge it. So there's two things that can happen here. If we expand out, we don't need to expand that out. There's two things that can happen. There's something called selective ACK and the regular acknowledgement. It's two different things. Regular ACK. Okay, so two differences between that. Regular acknowledgement means I send a packet, you acknowledge it. I send another packet, you acknowledge it. Probably not too cool. Very inefficient because only one packet is in flight. And actually, let's turn that on. We want to see data in flight. Very useful. Let's go back to Edit, Preferences, Edit Preferences, Protocols, TCP/IP, track number of bytes in flight. Make sure that's checked. Click OK. Alright, let's see if we can find out number of bytes in flight. Let's see where we can find that out. Alright. If we look at our I/O graph, statistics I/O graph, there we go. So what the I/O graph shows us is the amount of data that's being sent. Right? Now we can change the axis, we could do all types of stuff, we can smooth it out. We could look at this every 1/10 of a second. Right? So you look here, kind of get a feel of the whole conversation, of your whole chapter, where things were transferring and where things were not. Then what you can do is you could go up here to Filter, TCP Analysis. Yeah, TCP Analysis. You don't have to type in the whole thing, but it will auto-complete for you bytes in flight. TCP Analysis, bytes in flight. Let's filter that out. There you go. It's going to crunch for quite a while if you have a lot of packets. Right. And let's see if we can find that here. Expand out all your windows, or all your, there you go, at the very bottom, sequence, ACK, analysis, bytes in flight. You're going to have to expand out this last guy here. And I'll zoom in. So bytes in flight, in my case, 1066. They're on the wire and we're expecting it coming our way. It's either that or we've shot that down the wire and the other side hasn't acknowledged it yet. Bytes in flight. Not necessarily a bad thing. You'll always have a decent amount of data in flight. Okay, let's see. Go back to filter. So we know that when you set up your TCP conversation, the first thing you're going to do is you're going to send out the SYN, S-Y-N. You could filter that one out very easily. TCP, oh, I'm still in typing mode. TCP.flags.syn. Enter. So this is all the TCP SYN that you sent out. And it's going to be you, and it's also going to be the other guy sending you TCP SYN. So as long as it's a TCP SYN, it sees it. Let's see if there's any TCP resets. All right, TCP SYN double equals 1. All right, so there you go. That's a little bit better. So as you scroll through here, you can scroll through and see if you expand out the flags under TCP, Transmission Control Protocol, and you expand out where it says flags, you're going to see the individual flags in there. And TCP SYN is set, and you see a 1 there. If you ever see a packet that has all 1s everywhere, so every single flag is set, that's known as a Christmas tree attack. And what that is you should never have a packet that has all these set, because that doesn't make sense at all. It's like an acknowledgement push and fin, like the hell, what's going on here? But what that is some attackers, there's programs that can send that, and that will cause routers and switches sometimes to go nuts, because it doesn't make sense. We'll keep these flags open, but you probably noticed there's some that SYN you've seen before, acknowledgement you know about. It's the other side saying, okay, well, I see you want to start a conversation, let's talk. And fin means we're done talking. Now this urgent and this push you probably have never seen before. Push. Let's see if we actually have any push. TCP push. TCP flags dot push double equals 1. Do we have any that are push? Oh, look at that. Actually quite a bit. I'm surprised. Alright, so what the heck is a push in TCP? Well, you've got some buffers when you're sending over from one side to the other. So on the left side is you, on the right side is the server. So you make some data, you send it over, and there's a buffer while things wait, and there's a buffer while things buffer here before it sends out. Now let's say you have a very urgent message. You immediately want to send it over. You don't want to wait. You don't want to wait for the window to fill up or anything like that. So what you do is you make some data and you attach that push flag, and it tells the TCP stack, okay, just jam it over on the wire to the other side. So on your side, it just shoots it through. On the other side, the push flag, the TCP, the network card, the stack, the operating system is going to see the push flag set to 1, and it's going to say, dude, I got this flag, it's set to 1, shoot it up immediately. Don't wait for the buffer to fill, just fire it up. So send the data now, and send the data up the stack after I receive it. So basically, send it now. Don't wait. So that's the push. If we look for TCP flags dot reset, let's see if there's any reset in here. So TCP dot flags dot reset double equals 1. Reset is generally a firewall in between that kind of looked at you and said, what the heck, I'm nuking your connection. So you try to ping something, you try to go somewhere where you're not supposed to, and the firewall looks at you and says nope. Then what's supposed to happen according to the RFC is that the other side's going to stop the connection and send you a reset, an RST. And if you expand out any one of these packets, you'll see that reset is set, and that's a 1 right there. Okay. Now the problem with reset is there's 2 problems. One, you're providing the attacker some information because now I know someone is stopping me, is actually stopping me. So if we think about it, you know, you're trying to talk, you're trying to send something over somewhere to some server, and then in between, this firewall here sends the RST, sends the reset. Right? Now you know the IP address of that guy, and you know that something is in between. It's a horrible S, but so some guy in between stops your connection and sends you a reset. So now you know. So that's one. It's more information. But also let's think about this for a second. If you know that you can send a ping or you send some packet to a port and you get a reset coming back, so traffic coming back. Well, what you can do is, let's say you gather a list of 100,000 of these types of computers that automatically send something back. What you can do is you could spoof your IP address, write a script that like pings a whole bunch of these things, and just watch the fun happens. Well, you're not going to really be able to watch the fun happens, but basically sit back and laugh as 100,000 ping replies come back to a different address. Right? So if you have someone that you don't like, you could spoof your IP address to be that person and throw all the pings out and then have all the replies land somewhere else. The best analogy as I can make is you're in class and you tap someone on the shoulder on the other side and keep doing it, and eventually they think it's like some other guy behind them and they punch them in the face. That's exactly what's happening here in this case. They hit the wrong person. So TCP flags, very, very powerful, very, very cool. Okay, let's see here. Statistics, TCP stream graph. Oh yeah. If we go back to statistics, TCP stream graph, and let's look at the throughput graph, that third one there. Okay. I should have cleared out my filter. Clear out your filter. There you go. Clear out your filter, statistics, TCP stream graph, throughput graph. Okay, not too exciting here. Bytes per second. Now it will probably be dots everywhere. Yeah, that's not too exciting. I want a graph with some stuff in it. Let's see. Statistics, TCP stream graph, time sequence graph. Alright. Filter out for TCP, pick something, and then click on statistics, time stream graph, time sequence graph. Okay, finally. Okay, so this one looks a lot more interesting, just a lot better than just 2 dots. Okay, so what this is you can see that as we go along in time to the right, so from left to right is our conversation time. Our sequence numbers are trending upwards we have periods where things are kind of flat and then they go up. The reason they're going up is things are being acknowledged. Right here, it's going up very, very slowly. It could signal congestion. If you see kind of a very orderly, not too many jumps, but if it looks almost like this, then it means it's good conversation. If instead you see long periods of that, in this particular graph, we're looking at the time sequence graph, then that signals bad stuff. Okay. Now there's another graph type that we can do. You'll see you'll have this graph control. Another graph type is window scaling. If you click on that, crap. TCP stream graph, TCP trace. Okay. Go into your graph control, graph type, window scaling. There we go. Okay. So what you can see here, it's a pretty interesting graph. Shows your window size on the left-hand side, your time, and in my case I have a pretty straight line. I have a little bit of sawtooth, but not too much. So if this graph, this particular graph is window scaling, if this is pretty much a straight line, it means that you're able to receive and send without a problem. Or basically, for this particular direction, this was me going to 206.81, whatever that IP address was. So for me to that guy, my speed, my throughput, there was nothing really blocking me. I could send as fast as my NIC card could allow, and nothing in between was blocking anything, was dropping anything. Right, so this is cool for window scaling. This is the TCP window. How many of you see a graph that looks like this? A sawtooth or up-down, something like that. Something a little bit, this is sort of a sawtooth, but it's mostly flat. I'm looking for a little bit more pronounced. Alright, if you do see a sawtooth pattern, that means that something in between is dropping packets. The acknowledgement doesn't come back, and then what happens is that TCP window gets narrowed. So I get a ramp, then a flat top. Okay, so that's good. So if it looks kind of like this and this, Windows likes doing that. Actually, a lot of applications like doing that. So if you've ever put, or if you've ever started a transfer inside of Windows to another computer, or you're dragging a big file or whatever, you notice that you get this pop-up, not a pop, yeah, it's kind of a pop-up window, but you get this window that says, 30 seconds left, right? You're like, wow, 30 seconds, that's really fast. That's like a 20 gig file in 30 seconds. That's really awesome. But if you wait a little bit, that number goes up, down, all this stuff, right? So what's happening here is that window, that TCP window is adjusting, and so when you first started, it went like, whoa, went really crazy, and the prediction was based on that growth. Then it kind of stopped, maybe hit a bunch of traffic, went down here, and then that's when you get like the will complete in like 250 years or something like that, right? So what you see here is it found a window that it was happy with. It sent 1K, and 1K was acknowledged. It sent 2K, 2K was good, 3K, 3K was good. So then it hit a point where it said, whoa, I sent 5K or whatever, wherever it flattened out. And when I sent that much, I didn't get acknowledgement for all that. Something bad happened, right? And this is normal. This is okay. It's normal in Ethernet and TCP, right? And it flattened out, and that was kind of the level that it was happy with, and that's kind of fine. But what's bad is if you have the sawtooth. The sawtooth is boom boom, you know, stuff like that. Right? So it's a hard graph to get to. Sometimes I have problems getting to it, but just to remember, you click on a particular stream. Better for you to filter TCP first to get out the junk. So filter TCP, you click on the stream, you go to Statistics, TCP Stream Graph, and you pick TCP Sequence Graph. Doesn't really matter which one you pick. Click there, move the graph over a little bit, and for the graph type, it's that last tab there. It's window scaling. Window scaling. You can also do there's different ones like round trip time. Round trip time is kind of ugly to look at. It's very ugly to look at. It's a bunch of dots, and it tells you how long it's taking packets to come back. You've got the throughput. Not that exciting. Once again, a bunch of dots. Window scaling is a good one. So what you see on my screen, where it was at looks like 12,000, and then it tried to bump up to like a little bit over 12,000. Or see what happens here, 12,000, and say, oh, let's try a little bit more. Let's go for a little bit extra, and then a problem started happening, and it kind of goes on this downward slope until it gets brave and jumps up again. And I think you can change this. Let's do a quick search here. You can be a little bit more aggressive. There's a slow start. There's different ways you can do this. But let's see here, TCP window BitTorrent. I'll have to look that up later. Yeah, TCP window scaling. I think you can change it in the registry, or you should be able to change it in the registry. I'll do a video in there later. Okay, so Raval says, I see a dotted line in window scaling. Yeah, if you zoom in, yeah. So mine is actually dotted lines as well. It's just or dotted, well, they're dots, but because they're so close together, it looks like a line. All right. Okay, so some troubleshooting. If you saw the TCP flags, so TCP flags dot reset, we talked about that earlier. Reset double equals 1. Right? This is where you get the firewall basically saying no, don't like you, go away. And then what you have is TCP SYN. So TCP flag dot SYN equals 1. So let's say you've got a bunch of them together to the same guy. Let's see here. This might be a possible contender here. Okay, so in my particular one, I'm looking at packet 30,019, 2026. Okay, these are all TCP SYN by itself. All right, so TCP SYN, that doesn't count. This is good. Thought I was onto something, but here we've got SYN, ACK. Yeah, that's a normal conversation. But if you had packets that were just TCP SYN, TCP SYN, TCP SYN, like 3 SYNs in a row where you didn't get acknowledgement. Okay, cool, 5 minutes. You get 3 TCP SYNs in a row but no acknowledgement. That means that no one's home. Like you're trying to hit a non-existent system, or it's being silently dropped. Right? So the firewall is silently dropping. A lot of firewalls actually silently drop you, so it's not that big of a deal. Another common thing that you'll run into is very simple. The subnet mask is set wrong on the computer. So it thinks computers are remote when they shouldn't be. So it's ARPing for the wrong one. ARPing for the wrong machine. And that's very common. Okay. So the main thing to remember is the TCP flags. Very, very good. Knowing how to look at that window statistics. So it was statistics, TCP stream graph, and picking between the window scaling and the throughput and all that good stuff. You know, knowing where to expand out the flags. So just because you see TCP flags.syn, that just means one is in the SYN. There could also be an acknowledgement as well. So on my particular one, yeah, one is in the SYN, but there's an acknowledgement there. But because there's one there, it's going to match this particular one. Now what you could do is you could do a compound. You could say TCP flags is equal to 1, but the TCP acknowledgement, but not the ones that acknowledgement also have a 1. You know, something like that, to filter that one out. So that would be a compound that you could do. All right. So there's a lot more you could do with TCP IP analysis. In the future class, we're going to do like DNS. We're going to delve more into ARP. ARP is really fun. In fact, we could just we'll finish it up, go back to filter, type in ARP. Let's see if you got anything with ARP. Hey, look at that. We got stuff with ARP. And if you scroll over to the right, look at the information. It says, who has this? 172.18.182.1. I know that is my gateway. So you should probably see your gateway maybe somewhere in here. So that's my gateway. Tell me. I'm .62. And you have the ARP reply. Hey, 172.18.182.1 is telling me that his MAC address is that. Right. How many of you have ever had a duplicate MAC address, not duplicate MAC, duplicate IP on the same network? Duplicate IP at your network. What you're going to see is you're going to see ARP replies come back. You're going to see that basically another MAC address comes back. So in your ARP table, it's going to say like ARP 172.18.182.1 has MAC address A, and there'll be another entry. You'll have multiple ones, like you might have 3 if it's really bad. It'll look something like that. So same IP address, whole bunch of MAC addresses. And also another way to troubleshoot that is if you ping that IP address, so the suspected IP address, you have one ping that is successful and one ping that gets dropped. So it alternates. Good, bad, good, bad. So that means the ping went to one MAC, it replied, it went to the other MAC, and it died, and then it just flip-flops. So you may see that when troubleshooting duplicate IPs. Alright, so that was it for our session 5. This was covering the expert system and also covering a little bit of TCP IP analysis. I got way too many graphs open. Alright, the TCP handshake, we talked about the relative sequence numbers, talked about the window size a little bit, how to get the flags on the filter. Pretty important stuff, and the expert system as well.